Thank you for having me here. It's a pleasure to be able to present here to this audience. My talk is about development in notebooks and actually the production grade development in notebooks. My name is Jiří Vinárek. I work in Mews as staff data scientist. And if you haven't heard about Mews, it's a company that delivers hospitality solutions, software typically for hotels or hostels. And we have about 10,000 customers, mostly hotels around the world. And just recently, in January, we have become like a most valuated startup here in Czech Republic with valuation over $2.5 billion. But today, I want to talk about production grade development, so let's start with a quick poll. Please stand up if you have ever heard that notebooks are just scratch pads and they are not suitable for like a real development. Okay. Yeah. All right. That's fair. Please. And now, keep your hand up if you have ever been asked to rewrite your code, rewrite your notebook into something that will be real and like production ready. I see some hands up. Okay. All right. I will not ask whether you asked this question or gave this command, but I mean, we have pretty like significant chunk of audience. So now I feel that we are collecting some data, which is great. I have heard that too, actually. So I would also have a hand up. And today, the goal of this talk is actually to challenge this assumption that you cannot ship a production-ready code in notebooks. I want to say that what you will hear is nothing new. Most of the ideas you will hear from me are old, but maybe you haven't heard them before, so I'm not ashamed to share them. This idea of literate programming comes from 80s, and the author of that is Donald Knuth. So apart from the other amazing things that he did, he came up with this idea that when you have a programming code, it shouldn't actually be separate from the documentation. It should be like a single artifact where you not only describe what has been done, but also why it has been done. So it's like an intervened artifact, a code that self-explains the code and with the documentation that you put there in. Also, it somehow binds to this idea of exploratory programming, which again is also not new. It comes from 70s, from Alan Kay, where he took I think it was Smalltalk, and he just like had this idea of exploring the problem by exploring, like using the environment itself for exploratory work and exploring the idea and the solution. But back then, probably the idea was ahead of its time. It didn't really took off. But not that long ago, actually notebooks make this finally a practical thing. So you can do now the literate programming. Not now, I mean, it's been here for at least 10 years, but like now it's like really something that is like used in many systems. Okay, one of the inventors, or I would say most prominent figures that use this approach is Jeremy Howard from Fast AI, or now Answer AI, and he brought it to life with the use of NBDev. I'll talk about this tool later. It's been used, this approach as a whole has been used in companies like Netflix, in Lyft, and the others. And Chris Lettner, whom you maybe know from Swift or as an author of LLVM, he said that this is like a huge step, and it's something that is really, really useful. So the idea is, or the best practice is that, okay, I have a notebook, and from that notebook, I would generate a single Python module. The logic where I want to test the written code lives also in the notebook. And apart from the code and tests, I also have a documentation, so the prose that explains why and not just what has been done. So then the notebook produces the documentation, the libraries, and the test suite. So it's like this 3-in-1, you know. I have seen that before. But all right, so now how does it actually work? Let's do a demo. So, you know, I'm a data scientist. I like notebooks. Often we start with an exploratory data analysis. So for this demo, I have an example of, I used a Prague integrated system data set that is available online. And let's pretend that I want to explore this data, right? So as a first step, I need to load this data. So in this cell, I'm just getting the data set. Then when I verify that I got a response, I want to have a look on this data. So I see that I see the structure. There are some nested JSON fields. And then I want to explore it more, right? So I want to have like a visual grasp of the data. So looking just at a subset of data, I can see that, all right, you know, these are bus stops, train stops that are from the Prague integrated system. And maybe I want to have a larger sample and visualize it. So like, all right, this is Prague, and these are you know, the like different stops. Maybe I want to see a heat map, so no problem, right? Here's the density of these stops in Prague, and like, you get the idea. So this way, I'm exploring the data more and more. This is the distribution of bus stops, train stops, tram stops, and so on. Maybe I want to have a grouping by the type of the transport. So I want to visualize different stops on the map. And so on. So I can have a look at the table, right? I can also check the zones of these stops. So yeah, maybe if I zoom out, you can see that with Prague integrated system, you can get pretty far. I was actually surprised that, you know, the Prague integrated system, you can go also to Poland, no problem. So yeah, to Liberec, to Karlovy Vary, yeah, halfway to Brno. Yeah, so that's the first step, right? But then when I find that this data set is useful, often the case is that someone asks me to, all right, let's get this data daily, you know, let's scrape them daily, and let's save them into data lake. And this is not anymore a data science task. And Sometimes you have a dedicated team that handles this kind of tasks, data engineers. And what is interesting is that they are using often like a different tool set. So no longer you use notebooks, you switch to just Python code, to the like a production ready stack that you will use. But you don't have to do that. You can write the notebooks, but there's this catch that the notebooks can like quickly become a mess. But it doesn't have to be this way. They can be nice and tidy. So I will show the workflow that we used on one of our projects. The idea is that I would like to create a like pipeline task, and this task will be scheduled. It will download the data, save them, and then I will have like a sequence of steps, a data pipeline that will run daily. To do that, I want to really keep the logic in the task itself that will be scheduled daily pretty minimal. And the rest of the code, my goal is to put them into a shared module, which will be documented, will be tested, and then I will use this module. And to write it, I will again use the notebook. So I have a notebook. Here I have a notebook where I install all my dependencies, and I develop the code that will be used for fetching the data. And if you have noticed, it has special annotations or comments that are there in some cells, and they are there to mark cells which should be exported. So this way, I like tag the code that I want to move into the module. Right after the implementation, I have a cell that tests this code, and this way I'm building the library that I will then use. The last step in the notebook is this nbdev export, which when I run the code will export all the functions, all the cells that are marked for export into a into like a Python module. It's a code file where I have all the symbols that should be exported, like listed, and then it contains like the content that was inside the cell. So that's the basic idea. The nbdev, it is often run if you are not using Databricks. This is not something that is Databricks specific. If you are using local development with Jupyter notebooks, often the case is that this command line tool is executed as a pre-commit hook. Or if you are using Databricks, because it doesn't support now pre-commit hooks, you can run it in like a last statement in the notebook. Also works fine. So then this is the first task. I fetch the data. Then I have another task in the pipeline that just takes the data from the volume and loads it into the delta table as it is. And the third one, it's my attempt to do a CD2. So the library code is a bit longer, but so far it works fine. So it's all documented, it's all tested. So that's the development. The second important thing, apart the nbdev, is the inspection or the peer review of the code. For that, because the notebooks are by default like not easily diffable on GitHub, we used a tool called Git Notebooks. It's an application for GitHub, and you can then see what has been changed. You can add comments. You can see the charts, and it's pretty easy to use. So that extends the workflow for a review. And I think that's the main idea. I can also test the task itself because it takes like input location of the data and typically also the output location of the data. So I can test it in my local playground, and then if I want to deploy this, then I can also pass parameters that will override these values that are there passed through widgets. Actually, not related to the notebook workflow itself, or something that could be used also for the other workflows, is the deployment of the code. I don't have GitHub action, but imagine that this automation would be, the deployment would be run when I create a PR. So for each pull request, we automatically create a schema in the dev catalog, and then once we merge the pull request, the schema gets destroyed, and we promote the code, we deploy the code into production catalog. So this way we are able to even like see, isolate the different PRs, and if needed, we can also run different versions of the pipelines that are again like destroyed once the PR is merged. So I think that's in short the main idea. So EDA in notebooks, library notebooks, then separate pipeline notebooks, and we are using NBDev to export actually the code from notebook to like a standalone Python file. Yes, but that's just like a minimum that you can do. You can do much more if you want. You can publish the package to PyPy or Anaconda. You can auto-generate documentation sites. You can do CI/CD with pre-commit hooks. You can publish the documentation as Confluence page. And I would also like to mention that like this whole idea of literate programming can be taken to the next level. So if this is something that you would be interested, definitely check this Solvit tool, because it's like a dialogue-based development with deep AI integration, and like it's something I haven't seen before. So definitely recommend. It's like a power tool, really. Yeah, I think this idea is really powerful, and it's even more powerful now with the AI, because through the like a well-written prose, the AI can work better. So it's like a natural fit for assisted development, where you can like put the information into the context of an assistant, and it will perform better when the code is well documented in the notebook. Okay, so key takeaways. I hope that I have showed that notebooks often are scratchpads, but it doesn't have to be this way. And with the right workflow and with the right tooling, you can get like production-grade tool. one source of truth, all lives together in one place, and it works pretty well with AI-assisted development. So thank you for your attendance, and I will be happy to answer your questions.
Right, thank you. So again, thank you, Jirka, for your talk. And now there is a time for any questions from the audience, if you have any.
So I get you coming from notebook development for data science.
Mm-hmm.
This is functional programming.
Mm-hmm.
How do you handle you want an object? If you want to integrate 1,000 tables from a source, then you sort of need some kind of an object, and that object is usually modeled best as this object programming. And I think that is the downside of this way you cannot represent that. It's not, it doesn't have to do it, right?
Okay, I'm not sure that I heard the whole question, but what I understood was like how well the notebook-based development plays with object-oriented programming, where you can have like a large object or large class, and it contains many methods and many functions. Great question. The answer is that you can solve this. With the Fast AI library, you can use not annotation, but it's this like ampersand, this how it's called in Python. No, I mean the decorator. That's it. Sorry. You can use the decorator to add a function as a method to the class. So this way you can really like slice the logic, and this way you can like patch the class that is there.
I think the downside of the notebooks is that it doesn't really have the development toolkit. Like I know Databricks is kind of fixed some of the problems, but still compared to IE, it's like very low level.
Mm-hmm.
I think there's still some steps Databricks also developers need to take, but it's going the right way, but it's still not there. It's
Mm-hmm.
Yeah, I guess it's not fully fledged IDE like what we have in Databricks UI, and sometimes like you can find more powerful tooling in local development IDE tools. Sort of like follow up on this, how do you see like code reusability being applied in like this scenario with notebooks? Do you have some examples where you can easily like reuse code that was built somewhere else or some libraries?
I think this gets easier if you deploy the code into the package repository. If you have a way how to do that, then you can easily share the code. Actually, if you go to the FastAI website, it is really easy to spin up a new project and deploy it into PyPy repository, and it will have the documentation page. It will you will be able to see what are the test cases. It will also add CI/CD integration out of the box, so you can get pretty far with this.
All right. Any other question?
Are you talking about mostly notebook offline or notebook online? If you're online, you can use external resources.
You can use this workflow for both local development, or also you can use it like running in cloud, where it can easily be like the advantage might be in we are on the Databricks meeting, right? So like one advantage that I see is that the notebooks won't be flying around. And you can like scope the access to data, but also to the code, and you don't have to do the local development. Sometimes it like you want that, and sometimes not, right? So, but you can also like this is not Databricks specific. You can use just local Jupyter Notebook development. It will also work fine.
Another question on the same time. Are you talking about, do you take into account the strength of the resources of the node and node? You say, it doesn't matter if it's 8 gigabyte of memory or 2000.
Just repeat the question so that it's on record. So how do you handle, let's say, like resources specific for, let's say, the development or the notebooks during the development versus the production?
You can parameterize the notebooks. So you can have like a completely different, let's say, cluster configuration that will be used for development and then for production. That can be done. Like regarding notebooks, what we have seen is that because you often want to version control not only the cells but also their outputs, it can be pretty easy to end up with a very large notebook. So then you may hit some limitations on GitHub, where you get like over something like 1 gigabyte for a notebook, which is bad. I mean, you definitely the development flow needs some discipline on your side, how to structure the code and how to write and how do you scope it.
All right. Let's say last question, anything? If there is nothing, or?
What about application which uses inputs and outputs of computer and concurrent processes running on more cores?
I mean, it's like this development flow is really, it's universal in a sense that it can be used just on a small scaled machine having just a single core, or you can orchestrate with that large clusters that will have thousands of nodes. It has been used for data science, deep learning models. I see there a lot of value where you can visually inspect your outputs, and they are also version controlled. So in a few months, when the dependencies change, you will still see the state as it was when this code was developed. So you get like a snapshot, like read-only snapshot what has been done. But otherwise, you can use it. It's not really like data science specific. You can develop web applications in that. You can do like a system automation. It's pretty universal. It really is up to you how do you apply that. Embedded design. I mean, the best fit is like a Python code base. I have seen examples of code, for example. Not sure whether it was like this embedded development, but which I think often is the case that you use something like lower level. But I have seen that used, for example, for Mojo language or for JavaScript. So definitely you can do like let's say compute heavy operations with that.
All right, so that's all the time we have for Jirka. So thank you again for your talk.